Problem number 3. Solve the quadratic inequality x squared minus 7x plus 12 greater than 0. Write your answer in interval notation. Be able to justify your answer with a graph or sign chart. Okay, so the first thing that I want to do is mark off or make my number line. Just kind of give me an idea of where so I can mark off my critical values. And let's see, so the left side, if I factor the left side, let me write this again. This, and I set this equal to 0. This will factor into x minus 3 times x minus 4 equal to 0. And so I have a critical value at x equal to 3, positive 3, and then x equal to positive 4. So let's see, I'll mark let's see, 3 here, 4 here, and because I have it's a greater than sign, strictly greater than, then these are going to be open circle. All right. So now I have these intervals here, and it says I have to figure out which of these intervals, there's 1, 2, 3, which of the intervals include valid solutions for this inequality. So I can do, it says I need to be able to justify my answer with a graph or sign chart. So the way I have this number line here is I can continue on to plug in values from each of these intervals and plug in the sign of those numbers. If I get a positive value, then that means it's going to be a true statement. And actually, let me go ahead and show you. So for this one, the first interval, let's say f of 0. Okay, that lies over here in this interval. When I plug in 0, that's going to result in 12. 12 is greater than 0, but more importantly, this gives me a positive value. Okay, any value I pick in this interval here will result in a positive value, which results in a true statement, because all positive numbers will be greater than 0. So, you know, I can check this off, and if I go here, let me go down here and do f of 3.5. And let's see, f of 3.5 is, let's see, negative 0.25. Okay, so when I go up here to my number line, I get a negative value here. So this is not what I want, all right? Because a negative value is going to give me a false statement up here. So next, I go down here and choose a value from this interval, and so I'll do f of 5. Okay, so f of 5 is positive 2. All right, so positive 2, I get a positive, since I get a positive value here, that means any number that I pick in this interval here will be positive, and so that's what we want. Okay, so that's if I was doing a sign chart, you know, this is the approach to take to doing the sign chart. But if I'm doing a graph, you can graph this thing on your calculator. Let's see, I'll graph it down here. And when you graph this, you're going to get something that looks like this. So parabola, this is a quadratic, so the result is going to be a parabola. So this is going off this way. But let's take a look here at these key points here. Remember our critical values that we marked off for at +3 and +4? This is where it crosses, that's where it crosses the x-axis. Okay, so I have, this is 3 here and 4 here. But look at our inequality. We want all of the outputs that are greater than, that result in something greater than 0. Okay, so when I look at the graph, everything above the graph is what we want. Okay, and so everything below the graph, everything above the x-axis is what we want. Everything below the x-axis is what we don't want, because these values here, all of these values here, anything that I pick in between 3 and 4 on my graph indicates that I'm going to get something less than less than 0. So I'm going to get a negative value. So you can see from the graph, if I graph this thing, that the interval from -infinity up to 3 gives me, like, the graph is above the x-axis, meaning I got positive y values, and then between 3 and 4 it's below the x-axis, meaning I got negative y values, and then from 4 to +infinity I get positive values again. So this is a way that you can use your graph to indicate, like, where your intervals are. And when we write our answer in interval notation, we end up with -infinity up to, what did we say, up to 3, and then union with 4. Remember, not including 3 or 4, that's where the interval stops at. So we put a parentheses. So from 4 up to +infinity is the other part of our interval. And altogether, here's our interval notation.